Restart. First of all, I load R. I load R command. I change the working directory. Okay, and now I load the usual workspace, which contains the questionnaire data. I tell it to our commander. Okay, I first of all take a look at them. Okay. Now, until now, we have always seen, well, techniques which were applied to our data as they were. So no way to change our data, to fix them, to make small adjustments to them. Here we'll see some techniques which let you slightly adjust your data in case you want to change something or create new variables. The first one will be how to restrict the data set. Restricting means either remove some variables. It's a good idea in case you have 2000 variables and you always get lost, okay, but it's not so common. Much more common is removing some cases. For example, because you don't like to perform your analysis on female subject, you don't like to perform your analysis on widowed people. Okay, let's see how to do it. You must have your dataset loaded, active dataset, subset, active dataset. So selecting only some variables is very easy. You just uncheck this one and select the variables that you want. Okay. You give the name of the new dataset. Okay, you press OK and it's done. But honestly, for this case in which you have very few variables, it's not the case, so we'll keep all of them. We'll instead put a subset expression. For example, we will remove all the female people. So we'll subset with expression sex equal equal. Equality, you have to put two equals. Open quotation male. Unfortunately, you don't have to use the number, so the numerical code, okay, as it's typical in other statistical programs. You have to use the label. Using the label has the disadvantage that first you have to remember that you have to put the quotation. We'll see later whether single or double. Second disadvantage, you have to remember whether male was written with a capital M or with a small cap. This is the reason why I took a look before view dataset, just to check that male was written with a small m. Press OK. Always check what it writes here. 121 cases and 29 columns. So we have roughly half the cases, so it's correct. If you see 0 rows, it's because you have written a wrong expression. Now take care that you have the new data set, so the one containing only male. Let's take a look at it. You can see it contains only male. Okay, so pretty easy. Let's go back to the original one. Okay, subset again. Subset. For example, let's call it dataset 2. It's a good idea to change name every time, because if you overwrite the old subset, the old sample, age larger than 25. So we exclude people from 18 because it was smallest age up to 25. Okay, pay attention that you have always to specify the condition which includes people. Sometimes in the exam I will be so evil to write build a new data set in such a way to remove all the people younger than 25 or younger than 26. And if you put smaller 26, you are including the people younger than 26. Okay. So pay attention. This is the people who we want to include. Okay. If I ask you the people who want to exclude, you have to mentally reverse the condition. 228 rows. Take a look at it. Yes. Okay, so pretty easy. It's used much more often than what you believe, because many times you have data that you want to get rid of because you don't want to perform the analysis on those people. Okay, let's go back to our main thing. Okay, so let's put a note here for the next people. Okay. So just in case next time we will remember it. Okay. How to remove cases with missing data. It's a different thing theoretically, but in practice the same thing. Usually it's not necessary to do it, because whenever you perform a statistical analysis or any statistical calculation, a case with a missing datum on that variable is removed. Is excluded from the analysis. Okay. This task here is to remove all the cases which present any missing datum. So if a case presents just one missing datum, doesn't matter where, it will be completely removed from the new subset. So let's see how to do it. Remove cases with missing data. Data set 4. Okay. You see, many of them have been removed. We have only 23 rows because each one has us not a variable in some variables. For example, smoke num, number of cigarettes smoked, for many of them it's not a variable. So all the non-smokers, it was not a variable, except this one. So usually this is not a good idea, but if you are sure that most of your data are clean and you want to completely get rid of cases which have one not a variable, doesn't matter in which variable, you can use it. Okay, let's change and use switch to recode. First of all, I go back to our original question or data set. Recode. It's used to create and modify factor and other vectors. Vectors and other variables, sorry. So nominal and ordinal variables. You can either create them starting from scale variables, so grouping scale variables, or you have already a nominal variable, but you want to change the way it groups people. Okay. For example, suppose you have a variable with a city. Okay, you want to change Bolzano to here. You want to change Munich, Hanover, and Bonn to Germany. Okay, and you want to change everything else to others. So you are regrouping your nominal variable. Your nominal variable maybe has 200 cases because each subject writes its own city. In this way, you regroup it to 3 cases: here, Germany, others. Okay, or you can do it for numerical vectors, for numerical variables, not vectors, variables, for scale variables. Okay, grouping everything from 8 to 27 to high, everything from 0 to 7 to small, 28 and up to very high, and things like that. Okay, let's see some practical examples. Take a look at the questionnaire. For example, what do we do? We take here all the people. Okay, I want to change trade training post-secondary training. Okay, I copy because I will never remember it. Okay, I want to move it to, let's say, undergraduate degree. Okay. All the other coding will remain the same. So the only thing I will do at this one will be equal assigned to undergraduate degree. Postgraduate degree will remain postgraduate degree. Secondary school will remain secondary school, etc., etc. Okay, let's do it. Data, manage variables. Where is it? It's convert. No, recode variables. Recode, here, recode, the first one. Okay. So we want to recode add level. Do you want to create a new variable? Yes, add level 2. The new variable will be a factor. It's not possible to become an ordered. Okay, it will be a factor. The recode directive, unfortunately, you have to literally type it manually. Here are some instructions. This one will be equal to, say, undergraduate degree. Okay, we don't put any other recoding directive. I hope that all the other one will remain what they were before. Okay, let's see. So secondary, postgraduate, and secondary. Secondary, postgraduate, and secondary. This one, number 7, was trade training, post-secondary training. And now number 7 is undergraduate degree. Okay, so you can move some categories. Okay. We could do something more. We can also, for example, if I remember, there was a primary. Let's see. There was a primary school. Somebody. Okay, here there is a person with primary school. Let's move primary school and secondary school to school. Okay, and let's move undergraduate and postgraduate to degree. So we do a further grouping. Let's do it. Data, recode variables. So this one goes to degree. Then secondary school goes to school. Primary school. Unfortunately, if you spell it wrong, it will not work. So basically now we have two categories, degree or school. Because this one goes to degree. This one goes to school, degree, degree. So we have grouped primary and secondary school into school and all the other degree titles to degree. Oh, univ degree, just to. Okay. Okay, let's do it. Add level 3. Okay, take a look at it. Okay, you can see schools. Secondary school is school now, postgraduate degree is university degree, secondary school is school, blah, 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 blah. Okay. Sometimes is slightly easier to write them in this way. You can see here in the example. This example here. It's more compact. So C of, C means concatenation, of secondary school, comma, primary school becomes school. Okay. And C of trade training, post-secondary training, comma, undergraduate degree, comma, postgraduate degree becomes university degree. Unfortunately, this horrible screen, it's our default. The horrible screen doesn't allow me to enlarge it, so I have just to guess. C, secondary school, primary school. Remember the parenthesis becomes school. Okay, in this case, it's not ideal because I can't see it very well, but if you imagine you have shorter labels, you press OK, you're overwriting variable at level 3, the result is clearly the same. Sometimes it's even more interesting to look at here. Can you see? Because here you can see it much better. Here, the two conditions separated with a semicolon. Okay, let's do it again for another age. Typical thing you do. Let's take all the people from the lowest age up to 25 and classify them as young. From 26 to 40, middle. From 41 to 60, old. Above 60, very old. Okay. So, recode, clear, open. Age, the new variable will be age 2. So, how can we do it? Low, LO means lowest number, lowest value, to 25 equal, quotation, 26, 40 equal middle, 41, 60 equal old, 61 high equal very old. Okay, so you can use also low and high, which means the lowest value in the data set, and high the highest one, and this column, which means from to. Okay, it's here in the example, together with low and high. Press OK, and let's see it. Old, middle, let's see. So 42, 54, 41, 39, yes. There is somebody young, number 15 and 16. Yes, young. Okay, so you can either recode the nominal variable, or reducing the grouping, or rearranging the grouping somehow, or recoding scale variables and producing nominal ordinal variables. Well, unfortunately, the variables that we have created, if you look at the data set, so you type sleep questionnaire. No, sorry, you type structure of sleep questionnaire. The variables that we have created, it's a factor, so it's not an ordinal. If you really want to convert it to an ordinal, we have learned a way to do it. Sleep questionnaire $age 2 equal sleep equal or the red sleep $age 2. So you take age 2 from sleep questionnaire and you apply ordered and you put it again inside sleep 2. Let's see. Okay, now age 2 is an ordered factor. Well, unfortunately, the levels are wrong. They have been recoded in alphabetical order. Okay. One of the big problems of R. So it would have been better to leave it as factor. Okay. Massive recoding. Sometimes you have to do this task, well, for age not, but other cases, you have to do this task on 20 variables, which all are the same. For example, in our questionnaire, here we have 3 variables. Suppose I want to record the answer from 1 to 4 low, 5, 6 average, from 7 to 10 high. Okay. I don't want to do it for this one, and then redo it for this one, and then redo it for this one, and then redo it for this one. Okay. I want to do them in mass recoding. Okay. It's possible to do it. Reset. Okay, so we pick the variables which are involved, which are health, fitness, weight, and sat, sleep, fit rate, health rate, weight rate, and sat, sleep. Why are they called fit? Health rate, fit rate, and weight rate. Okay. Okay, so I select them. There are 4 variables. Can you see here, new variable name or prefix for multiple records? So if you select more than one variable, here clearly you don't type the new variable name because you have more than one, but the prefix, so recorded underscore. In this way, it will create 4 new variables, which will be called recorded sat sleep, recorded health rate, recorded fit rate, and recorded the other one, weight rate. Let's put the recording 1, 2, 4 equal low. You can assign also numbers if you want. 1 to 4 equal 1, 5, 6 equal 2, 7, 10 equal 3. Assigning number is very good in case you plan to use it as an ordinal variable later on. Okay, and now it will be recorded into 4 new variables which will have the same name but prefixed with recorded. Okay, that's it. Oh, can you see? Recorded fit rate, recorded health rate, recorded sat sleep, recorded weight rate. Okay, but names 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. So using this little tool, it's possible to do massive recording. So if you have several answers which look all similar, you can record all of them at the same time without going through them one by one. Okay, let's see another task which is similar. Okay, it's binning. Okay, while this thing can be done also with recording, okay, binning is more focused on it. Binning basically takes a scale, group scale variables. It groups the value of a scale variable. Okay. It theoretically produces an ordinal variable because if you group a scale variable, you produce an ordinal variable. But in R, it produces a factor. Okay, where is it? Our commander data manage variables in active data set bin numeric variable. Data manage variable in active data set bin numeric variable. Okay, we take as usual age, new variable age 3. We have already used age 2. Okay, how do we bin? Well, while before in the recoding you choose the binning method, okay, here the binning method is chosen, well, not chosen by R, but it's automatic binning method. You can choose an equal width bins. It means that you will create, let's say, 5 bins of equal width, probably from 18 to 28, from 18 to 27, from 28 to 37, from 38, etc., etc., or an equal count bins. It will create bins which are of different sides, but inside you will have the same number of people. Okay. Or it will use this k-means clustering, which is an advanced statistical technique to create bins. Okay. Moreover, how many bins? Okay, let's take, for example, 5 bins. Okay, let's say equal count. Okay. Moreover, your bins will have names. Do you want the bins to have numbers, so 1, 2, 3, 4, 5, or ranges? So the first bin will be called 18 to 24, the second bin 25 to, let's keep ranges, for example. Okay, done. Let's see the result. Okay, so this person is in bin from 41 to 48. This person is in bin from 48 to 56. This one was not a variable, is still not a variable. From 32 to 41, etc., etc. This person is in bin from 18 to 32. So it has created 5 bins as requested. The name of the bins are exactly the interval considered. Okay, and the bins have been created respecting the proportion. So the amount of people in each bin should be equal or at least almost equal. Let's check this thing here. So how do we check? With frequency. I ask frequency for age 3. Okay, you can use in the first bin I have 54 people, in the second 51, 53, 44 and 46. Probably there were a lot of people of the same age and the program couldn't do any better. So we have these two bins a little. Okay, so it's automatic, while if you want to do decide yourself the bins, use recode. Okay, let's go to the last one of this tool, but the longer and the more interesting, compute. Okay, compute is used to create a new variable through mathematical operations. Okay, so basically you can do mathematical operation on one or several other variables case by case. So the operation will always be done case by case. And you will at the end create a new variable. Okay. Let's see. Our command data manage variable and active data set compute new variable. Okay, here you have. So suppose we want to create a new variable called ABC, okay, which is equal to 2 times the age, okay, plus the number of alcoholic drinks, okay, plus 3 times the number of caffeine you drink during your day. Okay, so a strange variable, or let's call it appearance age, health age, and let's put age. Okay, so age plus the number of alcoholic drinks plus 3 times the caffeine. Okay, so health age. So if somebody drinks caffeine, his age will be increased. Okay, so pretty easy. Let's see. This person is 42 and this person is 54. Becomes 60 and 84. Okay, after huge people. Okay, so you can create this kind of variables joining together through any mathematical operations that you want. The mathematical operations which are available are these ones: plus, minus, multiplication, division, and power. You have also the square root, sqrt, and the logarithm. Honestly, I seriously doubt you will use them. Maybe the logarithm, ln or log. Okay, so pretty easy. Okay, it's easy. However, well, it's pretty strange that there is a specific menu to do it. Why? Because look what R has written. Okay, this one. Okay, R has written sleep questionnaire $health age, so the name of the new variable. This is an assignment symbol. It means what is on the right must be assigned inside the left. Okay, forget about the width. Age plus alcohol plus 3 by caffeine. Okay. The width means that these 3 variables are found inside the sleep questionnaire. So it's telling us insert a new variable health age inside sleep questionnaire, okay, which is equal to this mathematical formula where the variables involved will be found inside the sleep questionnaire. So width means the variable here will be found inside the sleep questionnaire. This is perfectly equivalent to writing this thing here. So without a width, dollar plus I dollar dollar. So the width is just to avoid having to write every time sleep questionnaire dollar. So health age inside sleep questionnaire is equal to age inside sleep questionnaire plus alcohol inside sleep questionnaire plus 3 times caffeine inside sleep questionnaire. So perfect equivalent. Okay. So the compute command, which is here, where is it? Here. Has produced this thing here. You could produce manually this thing here. So honestly, what the compute command does is nothing else but something you can type manually with your fingers. Okay, let's see. Here's what I write. The instruction written by compute, in this case it's uptake variable by 7 minus the square root of conc variable, can be typed directly by you. The rules, in case you want to type the things directly, is that the variable name must be preceded by the dataset name and dollar, because you are working on variables inside a dataset. And this symbol here, which means take everything from the left, from the right, and put on the left. Okay, let's see another example. Suppose I ask you, let me see which variables do we have available. Ah, yes, build a new variable, scale variable, which is the ratio of weight divided by the square of height. You know, it's one of the indexes which can measure how fat you are. Okay. Or better, 10,000 by how much you weight divided by the square of your height. So I will write it here. So 10,000 by your weight divided by square of height. Okay, so the new variable will be fat. Okay, let's do it. First of all, we will do using the second technique, so the manual technique. We'll write it manually. Use it at its equivalent or even sometimes shorter. So, no. Sleep questionnaire, dollar, fat. The only boring thing is repeating sleep questionnaire every time. But if you choose a shorter name for your data set, for example, SQ, it's much faster. 10,000 by sleep questionnaire, dollar, weight, divided by, how can I tell the square of the height? Well, I bet that some of you will do it like this. Maybe with some parentheses, otherwise it will never work. If you don't put a parenthesis, this thing will never work. Well, if you do this without parentheses, I will mark it as a severe logical mistake. Okay. If you do it with a parenthesis, I will mark it as a non-severe mistakes, because you are showing me that you don't know that in order to raise the power, you can just write it like this. So asterisk is the symbol which raises something to power. Okay, let's see. Submit. Let's see this fat index. Yes, it's a famous index. If it is above 25, you are overweight. So underweight. Below 20 is underweight. Overweight. Let's see. There should be a person which is extremely overweight. Okay, underweight. Oh, there are people under 40. Okay, it's a famous mass index. Okay, well, let's do it with the compute command. It's the same, So reset variable, let's call it fat2, expression to compute, 10,000 by weight divided by height. Okay, honestly, writing with the computer, it's a little easier because you don't have to continuously write sleep, question, or dollar. Press OK. Can you see the result? It's the same, but the computer prefer to use the with approach. Let's see whether the fat2 is equal. Let's see. You can see fat2 is obviously the same as fat. It's calculated using the same formula. Okay. So pretty easy doing the computing with the compute command or with your fingers typing the things manually if you prefer. Okay. Let's go now to something a little different, still concerning computing. What happens if you forget to specify dataset dollar or if you don't want to specify it? Well, if you don't specify it, you will create a variable outside the dataset. So variable can also live outside the dataset. They don't necessarily need to live inside the dataset. Okay. Usually the variables that you're going to create will have, however, only one case, unless you will do something strange, which we'll discuss later on. Okay. If you want to take a look at your new variable, you just say print variable. Let's see some little examples. A, it's the name of the variable. You can see I don't write sleep questionnaire $A. In this way, I will create a variable inside the dataset if I type A equal to 23. So I'm creating a new variable A with one value only, so only one case. It doesn't contain several cases, only one, 23. If I'm curious and I want to take a look at it, I just can type print A, 23. Or if you prefer, just simply A. But print A usually works better, 23. Okay, you can use mathematical expressions, for example, so B can be set to 7 plus 8 minus 9 by A. So you can use mathematical expression and also mathematical expression involving other variables. Let's take a look at the value of B. You could theoretically just type B, but I prefer print B so it's very clear what I'm doing. Minus 192. If you want to look at the structure of B, it's a number, okay, with one element only. Okay, so in R you can, and many people use this one, so I tell you, few people work with data sets. Most of the people work with variables directly. So you can use variables directly without a data set. They will be stored inside the memory of R. They don't need to be stored inside the data set. However, they will have only one case unless you build variables with several cases. And let's see now. Yes, there is only one final thing that I want to tell you. You can type also something like this in mathematics will be considered a mistake. B cannot be equal to B by 2, or better. Okay, B cannot be equal to B plus 3. Okay, there is no number which is equal to itself plus 3. In computer science, it's not a mistake. It means that take the old value of B, which is minus 192, add 3, it becomes minus 189, and put the result inside B. Minus 189. So you can also do some mathematical calculation with the variable itself. Okay. How can you create variables outside the data set? You can also write in the opposite way. Instead of variable arrow pointing left value or formula, you can write value or formula arrow pointing right variable. It's a very strange way to write things, but it's possible. Okay, you can also build variables outside the dataset with more than one cases. In this case, they are technically called vectors. And now you understand why in the rest of the video I have always had to correct vectors somewhere. Okay, well, if you want to create it manually, you can do it like this. Let's see. D equal C. C, it means concatenation. Don't use it as a variable, otherwise you create chaos. 7, 3 minus 2, 5, 23.4 minus 103, 75, 75,003. Okay, so this will be a variable containing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 cases outside the dataset called D. Technically called a vector. Print D. Oop, it's a vector with 2, 4, 6, 8, 11 numerical elements. You can create a vector also with non-numerical elements. A vector containing text. Okay. I don't suggest you to mix them up. I don't remember whether R will allow you, but don't mix number with text. Any computer program will complain. In case you need to take specifically one of the elements, you can use vector, square brackets, and the index. So, for example, suppose I tell you, please give me the sum of the third element of vector D with the fifth element of vector D, and put the result inside variable f. So f will be vector D, fifth element, plus vector D, seventh element. So this will take the sum of the fifth element of vector D. So this one, it's the fifth element, with the sum with the seventh element, 75. Okay. So now f 98.4. So in case you need to use specifically one of the elements, you can work like this. You can do it also vice versa. You can take the sixth element of vector D and change it. Set it to -1. The sixth element is currently -103. Now it's -1. Okay. If you need to use a range of elements, you can just write something like this. This means all the elements from 5 to 8. Let's print them. So we'll print the elements of vector D from 5 to 8. Okay. Now we'll set them to 0. I am setting all the elements of vector D from 5 to 8 to 0. Let's see. Print D. 5, 6, 7, 8. Well, 9 and 10 were already 0. Okay. So you can use this little thing here, vector with an index, to access a specific vector element, or vector from 2 to access a sequence of vector element. Please never put negative numbers here because they have a completely different meaning, which I don't explain to you. Okay. Another thing which you can do, if you want, you can mix the two things. So you can mix things in a data set with things outside the data set. For example, age outside data set is the name of the variable. You can call it as you want. You can call it John. Okay, let's call it John. John is equal to sleep questionnaire $age. It means that this thing will take age from inside the dataset and copy it, it's copy, not move, to John outside the dataset. So John will be a vector containing 237 cases. Let's see. Print John. You see, John is a vector containing 300 whatever cases. But now it's outside the dataset. You can see in your dataset you don't have John here. Okay. So you can take also things from inside the dataset and put them outside. If you want to do the vice versa, however, if you want to take a variable from outside the dataset, such as D, and put it inside the dataset in this way, So I'm taking D, which is outside the data set, and I'm putting it inside the data set with name D, 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 D. I don't suggest you to do it, because D has only 11 cases. The data set has 271 cases. I don't know what will result. Let's try, but I usually never do things like that. Let's see. Can you see? Error replacement has 11 rows, data has 271 rows. Can't match. Okay. So while you can take things from the data set and put them outside, inside variable outside, do it vice versa. It's a good idea only if the variable outside has this exact number of cases. Okay, let's see whether we have something else. No, we stop here with, let's say, programming things. I will not bother you with other things.